Hello everyone, myself Karthika from Sri Sai Ram Institute of Technology. So I am going to handle control systems. We are going to see an important topic called compensation in control system. Okay. So before that, we need to know about what is compensation. So in order to obtain better performance, in order to obtain the steady state and the transient response, we are using one compensator in a system. What is the function of a compensator? It will compensate the system performance in a predictable manner. Main aspect of the compensator is that it will introduce a pole and a zero in the system. Okay. Next, because of that only, an unstable system will become stable. So the compensating networks will minimize the overshoot. Mainly, as I already said, the compensating network will introduce pole and zero in the system in order to change the transfer function. If the transfer function itself is changed, what will happen? The system performance specifications will also change. We will get the required specifications. Okay? Next. Okay. What are the main methods of compensation? Mainly there are three methods. One is series, parallel, then series parallel compensation. First we see about the series compensation. Here, in the series compensation, we are introducing the compensator in a series manner. We already know a negative feedback system. So this is a closed loop feedback system. So this is a negative closed loop feedback system. Here, we are introducing the compensator in a series manner. Okay, next. Next one is the parallel compensation, which is nothing but we are giving some compensator internally, that is feedback. See here, we are having the compensator internally, that is we are connecting in a feedback manner. Next. And then series parallel compensation. In the series parallel compensation, what is happening? Both the series and the feedback, that is series and the parallel compensator are adjusted. Look at here. The compensator is added, series and parallel. So combination will give you what? Series parallel compensation. Next thing is, okay, we saw the main three methods of compensation. Next thing is, what are compensating networks? In order to make some adjustment due to the deficiency in the system, the performance will get reduced. Because of that, in order to make up the deficiencies, what we are going to do is, some adjustments will be made in the network. Okay? Because of some adjustments, my performance, that is the performance of the system, will get maintained. Okay? So, the compensating devices, mainly we are dealing with electrical. It may be what? Electrical, mechanical, hydraulic or pneumatic. So, the compensating devices may be of any type. We represent with the help of what? RC filter. So, the main classification of compensating networks are lag, lead network. Next thing is phase lag compensation. By the name itself, we can understand what is meant by phase lag compensation. The phase lag compensation will introduce one zero and one dominant pole. We know what is dominant pole. The dominant values are the values which are very close to the origin. Okay, so one dominant pole will be located. Because of that, it is called as what? Lag network. Okay. So, lag network is nothing but it will contain one dominant pole and a zero. Especially, it will produce a negative phase angle. Okay? It will produce a negative phase angle, or else we can say as what? Lagging angle in the system for all the positive values of frequency. So, we will be plotting the board plot in terms of frequency and the gain rate. So, for all the positive values of frequency, we will be getting what? Negative phase angle. Okay. Similarly, if comes one dominant pole means, for phase lag means, For phase lead, one dominant 0 will be there. And it will produce what? A positive phase lead or leading angle. Okay? Next thing is lag compensation. We are going to see all these topics. Okay? First one is realization of electrical network. We have to consider a network. From that network, we have to find out the transfer function, and then we have to go for what? Magnitude as well as the phase angle, and then we have to find out what? The poles and the zeros. That is S-plane representation. Third one is from that S-plane representation, with the help of the transfer function, we are going to find out the maximum phase lag, that is omega m, phi m. Next one is maximum frequency, that is omega m. Next one is the attenuation coefficient beta. From all those values, we are going to plot what? Bode plot and the polar plot. Okay, let us see in brief about the electrical network in the first. So, realization of electrical network. So, this is an RC filter connected at the output. So, the input is EI and the output is E0. You know how to take the Laplace. So, the transfer function, we know E0 by A of S is equal to R2 plus 1 by Cs whole divided by the total R1 plus R2 plus 1 by Cs. This will be obtained in a separate manner with the help of Kirchhoff's voltage law. Okay. Next one is we found the transfer function, that is G naught of S, that is E naught of S by A of S. That is your transfer function of lag compensator. Now we will represent in the pole zero plot of the lag network. We know. So this is j omega and this is sigma. So the transfer function we obtain from the RC network of lag compensator is E naught by E I of S is equal to 1 plus R2 CS whole divided by R1 plus R2 into CS plus 1. We need to have some simplification. So, we will take R2 divided by R1 plus R2, we will be getting S plus 1 by R2C divided by S plus R1 plus R2 divided by R2 into C. Okay. Now, this will be called as 1 by beta. Here, S plus 1 by T divided by S plus 1 by beta T. Okay. So, here beta is equal to R1 plus R2 divided by R2 and T is equal to R2C. Okay. In this, beta is always greater than 1. So now E naught by E I of S is equal to S plus 1 by T divided by S plus 1 by beta T. This is my transfer function of the lag compensator from the electrical network. Now we'll have the magnitude and the phase angle. How to find out? We'll have the magnitude M, which is equal to, we'll simplify this, 1 plus St divided by 1 plus S beta T. Okay, for this we have to find out the magnitude. How? Put S is equal to j omega. Okay, so we'll be getting root of 1 plus omega square T square divided by root of 1 plus omega square beta square T square. This is the magnitude. If you want to find out the phase angle means, that is phi is equal to tan inverse of omega t minus tan inverse of omega beta t. already informed, we have to find out the maximum frequency, that is omega m, maximum phase angle phi m, and then we have to find out the value of beta. Okay, how to find out the maximum frequency? Let us consider d phi by d omega m is equal to 0. For what? To find out the maximum frequency. Okay, so what we will obtain from this equation? That is 1 by 1 plus omega square t square into t minus 1 by 1 plus omega square beta square t square into beta t is equal to 0. You know tan inverse of theta, which is 1 by 1 plus theta square. Next, so separating the terms, t divided by 1 plus omega square t square is equal to beta t divided by 1 plus omega square t square. After some simplifications, that is t will get cancelled, we will get cross multiply beta plus beta omega square t square is equal to 1 plus omega square t square. Constant terms will be taken out in one side. So, beta minus 1 is equal to beta minus 1 into omega square beta t square, which is common, beta minus 1. So, cancel out beta minus 1, we will be getting 1 is equal to omega square beta t square. And finally, what is omega? Omega is equal to 1 by t root of beta. So, we found what? Omega m, that is maximum frequency. Okay? So, the first one we calculated. The next one is maximum phase lag, that is phi m. In order to find out the phi m, we have to take the phi value, that is tan inverse of omega t minus tan inverse of omega beta t. This one. How? Take tan on both the sides. Okay. Now, tan phi m, at phi is equal to phi m, what will happen? Okay. At phi is equal to phi m, omega is equal to omega m. Okay. So, tan phi m is equal to tan of this value. So, tan of tan inverse of omega t minus tan inverse of omega beta t. Able to understand what is the format?